Good afternoon, students. I welcome you all for the session. Today, we'll be going to discuss another important topic in the first unit, that is multiprocessor and multicomputer. And I know you are well aware of what is a multiprocessor and what is a multicomputer. What are the benefits and key advantages in the multiprocessor when compared with the multicomputer? So, everything we'll be going to see in this session. So let me tell you what is a multiprocessor. Fine. As the name itself indicates, like here, like when we are talking regarding this multiprocessor, as the name itself indicates, multi and processor. Here it is divided into two multi. The first part is multi and the second part is computer. Here is multi and the second part is processor. So multiprocessor and multi-computer. First we'll be going to study regarding this multiprocessor. So what do you mean by a multiprocessor? So a multiprocessor, what when we are going to say that it is multiprocessor, multi means many, processor means CPU, right? So here multi means when we are going to talk regarding multiprocessor, multi means many and processor in the sense CPU. So here only we got the definition. So many CPUs. So there are many CPUs which are going to connect together. So that we call it as a multiprocessor, right? So here, in multiprocessor is used for processing and executing instructions, right? So a wide range of multiprocessors are the shared memory devices. So this multiprocessor is very much useful. Why? Because here there are many models comes under multiprocessors. You don't need to discuss in that deep. So what do you mean by a multiprocessor in the sense? A multiprocessor is a computer system with two or more central processing units share full access to a common RAM. Fine. Here multiprocessors means many CPUs will be there, many processors will be there which are going to share a common one. So this is going to share a common one. I'll be going to show you the diagram. Don't bother about it. Fine. So the main objective of using multiprocessor is to boost the system execution speed. Why? Because as we are saying that it is a processor, many processors in the sense the execution automatically it will be very much fast. So when compared with the single processor, we can expect a fast execution in multiprocessor. Fine. This is the main objective of multiprocessors. So there are two different types of multiprocessors. The first one is the shared memory multiprocessor and the second one is the distributed memory multiprocessor. So shared memory and the distributed memory. So in shared memory multiprocessors, all the CPU shares a common memory, that is the shared. So when we are talking regarding the shared, here they are going to share the memory. When we are going to talk regarding the memory is distributed to each and everyone. They are not depending on one memory. So and the distributed memory is very much advantage. Why? Because suppose if any for example I'm going to teach you CO. Fine. You people are in A section 60 students are there, B section 60 students are there. So here it is A section, it is B section. So when myself is going to teach for the 60 students, when it is the shared one in the sense, if Anita is teaching for CSEA and some X is teaching for CXCB, then there won't be any problem. Suppose if only myself is taking for 3 or 4 sections, so it will be going to get clumsy. And if I'm not feeling good, all the sections have to suffer a lot. Fine. If it is in shared one, why? Because shared in the sense, A section is going to take myself, B section is going to take by X, C section is going to take by Y, like that. If I'm suffering, only A section will suffer at this point. B, C, D sections, they'll be going to run as usual. So I think you got my point. So that is the shared memory and a distributed memory. So when the work is distributed among many persons, or when the work is distributed among two or three people, what it is going to happen is, like the task, the things we can complete it very much faster. Got it? So if the task is not divided, if the task is not divided, only one person, single-handed person, I mean, if he want to handle that task by his own, it is going to take much of the time. His energy will be wasted, and the time will be wasted. Everything is going to be a drawback. If it is comes for the distributed, when we are going to divide the task between the number of people, like each and every person is going to do a single module, so that the task, like the first only single person can do the task in 1 hour. If 5 persons, in the sense, they'll be going to complete the task in half an hour itself, and the efficiency also will be very good. Why? Because a single person has to think the whole program. If that program is divided among 5 people, so everybody is going to get a limited lines of code, so that they can easily write that code, they can easily check the errors. Many advantages are there when we are going to talk regarding this distributed memory multiprocessor. Fine. So that is the shared memory processor and the distributed memory multiprocessor. So in distributed memory multiprocessor, each CPU has its own private memory. So that is the main advantage why this distributed multiprocessor is going to have those many advantages. Clear? So that is a multiprocessor. So as the name itself indicates, many processors we are having. What are the benefits when we are going to say, in the sense? The execution speed is going to be more, so that the performance is going to be high, and then the task is going to be completed within a limited amount of time. So what are the two types of multiprocessors, in the sense? Shared memory multiprocessor and distributed memory multiprocessor. Shared memory, in the sense, like many processors will be there, only a single memory they are going to share. Distributed memory, in the sense, each and every CPU is going to get its own memory, that they should not depend on any other. They can do their work very much easily. So that is the distributed memory multiprocessor. And this is the diagram of shared memory multiprocessor. Fine. Here, this is for shared. So shared memory multiprocessor. So here what they are sharing? They are sharing this memory. So here multiprocessors, in the sense, this is processor 1, this is 2, 3, 4, 5, 6, 7, 8 processors are there over here. All the 8 processor is going to share a single common memory. This is the single memory. So this is how the diagram of shared memory multiprocessor is going to be. Next one is the benefits of a multiprocessor. That means performance is going to be increased, as I have said you before. Multiple applications, like many processors, in the sense, many tasks we can do. Multitasking is going to be possible. Throughput and responsiveness is going to be more, and sharing, hardware sharing and among CPUs will be good. So these are the benefits of using the multiprocessor. And the next one is a multi-computer. So it is also, as the name indicates, multi-computer. So many computers will be there. Like computer, in the sense, like suppose take an example of your PC at your home. So that is a computer. So what the PC is going to have? It is going to have its own memory, its own hardware devices, its own processing unit. It need not depend on any other for any task or something else. So that the processing is going to be very much faster when we are going to talk regarding this multi-computer. So a multi-computer is a computer system with multiple processors that are connected together to solve a problem. They are not sharing anything. When we are talking regarding a computer, in the sense, a computer is going to have its own memory, it's having its own input and output devices, having its own control units. Everything is going to be different for each and every computer. I mean, separate for each and every computer. They are not going to share anything. So here you can see here, each computer has its own memory, and it is accessible by that particular processors, and those processors can communicate with each other through an internet. So through a network, we are going to connect all the computers so that they can share information. So a multi-computer is capable of message passing between the processors, right? How they are going to communicate? They are going to communicate by making use of message passing, right? Hence, a multi-computer can be used for distributed computing. So as we have seen in the previous slide, shared and distributed. Shared in the sense, a single thing is going to be shared by many computers. Distributed in the sense, each and every computer has its own memory, IO devices, everything is going to be separate. So that is the thing of a multi-computer. Here is the block diagram of a multi-computer. So when we are going to talk regarding a computer in the sense, a computer is going to have its own CPU and memory. So it is going to have own CPU and memory. So this is the first one, this is the second computer, this is the third one, like that, fourth, fifth, sixth, 7, 8. Here we are going to have 8 computers. So computer in the sense which is going to have its own CPU processor and its own memory. They are how they are connected? They are connected through interconnection or networking. So that is the multi-computers. So that is how we are going to differentiate between the multiple multi-processors and the multi-computer. Next, we'll be going to start the second part of your first unit, that is IO, input and output organization. So, what is an input and what is an output? Right? Like input in the sense through which we can give data, right? Through which we can give instructions to the system. Output in the sense how we are going to view the results, that is known as input devices and the output devices. So here we are going to study how we are going to access the IO devices, how we are going to access the input and output devices. So input and output devices are accessed through IO interface. So interface, so this is the main one in which we have to remember, fine. So without interface, we can't do anything. We can't connect the input and output devices. So what is an operating system? So operating system is an interface between whom? Between the user and the computer hardware, fine. So when we are going to talk regarding the operating system, what we are saying, it is an interface. Interface is nothing but mediatory. So mediatory part between whom? Between the user and the computer hardware. Why we need this interface in the sense, like user can't directly interact with the computer hardware. Why? Because computer hardware will be of zeros and ones. Will we know the binary language? No. Only computer can understand the zeros and ones. What the user is going to write, user can understand this high level language. So what to do is we have to convert this high level language into this binary language. So what we are in need of? We are in need of some interface. So this operating system is an interface which is used to convert this, which is used to act as an interface between mediator between this user and the computer hardware. So why I have said you the definition in the sense, by the term interface. Interface in the sense mediating between the things. So here how IO devices are accessed in the sense, these IO devices are accessed through IO interface. Input output interface are there. So what are the requirements for the input output interface? So in order to interact with the input output devices, so we are saying that this IO interface is mandatory. So what are the requirements in the sense? CPU communication is required, device communication is required, data buffering is required, control and timing, and error detection. These are the things that are going to be uh, that are required for I/O interface, fine. So first one is the CPU communication. So what do you mean by a CPU communication? CPU communication in the sense processor sends commands to the input-output system. So which are generally the control signals on the control bus. So like some printer is there. So this is the one I/O device. Here CPU is there. So if CPU wants to communicate with this I/O device, what it is going to do? It is going to send some commands to the I/O device. So commands are nothing but the control signals. That's what here we are saying. So this exchange of data between the processor and the I/O interface, how it is going to be done? It is going to be done by the data bus. Fine. We have studied in the first class. We are having the system bus. What the system bus includes? System bus includes data bus, address bus, and the control bus. So here, how we are going to exchange the data between this processor and the I/O interface in the sense by making use of a data bus, we are going to like exchange the data between the processor and the I/O. Right? Like we have to check whether the devices are ready or not. So the first one is the CPU communication. Next one is the data buffering. So what is the data buffering? So data transfer rate should be very high. So data from the processor and memory are sent to the I/O interface. So they are buffered over there and then sent back to the peripheral devices. So this is the data buffering. Error detection. So these I/O devices are responsible for error detection. Whatever the error it may happen, these I/O devices are capable of handling those error detection. So, what are the simple common type of errors in the sense? Mechanical errors, electrical malfunctions, battery crack, unintentional changes like divided by zero errors, all the errors are going to be done. Fine. So this is the block diagram that is going to show the I/O interface. Fine. See here the data lines, address lines, and the control lines. These are very much important. So these three we call it as a system bus. This data lines, address lines, and control lines we call it as a system bus. So here we are having the data register, status register, address decoder, external device interface logic, and the data status and the control signals. Fine. So this is the interface block diagram. So what the data register is going to do? It is going to hold the data being transferred to or from the processor. So if you want to transfer from the to the processor, or if you want to take data from the processor, we are going to store, or it is going to hold that data. That is the purpose of the data register. Status or control register in the sense what is the action that it has performed, what is the status of that particular register. So that information we are going to store in the status and the control register. And data on the status control registers are connected to the data bus. So decoder in the sense it enables the device to recognize its address. Fine. This is the I/O interface for input devices. See here, we have connected the input devices over here. So here I/O interface. This is an I/O interface which is going to make use of this control bus, address bus, and the data bus. So control bus is used for transferring the control signals. Data lines are used for carrying the data, and address lines are used for connecting the address. So here this is the I/O interface for input device. If for example if you are going to take I/O interface for output device, instead of keeping the input devices, we need to place the output devices here. So here we have to place the output devices. This is the I/O interface for output devices. Fine. And the next one is I/O interface techniques. So in this I/O interface techniques, there are many techniques will be there, but we don't want to go in that much depth when we are going to talk regarding this I/O interface. So when we are going to talk regarding this I/O interface, so accessing I/O devices. So how we are going to access I/O devices, that is major important, right? And when we are going to talk regarding this I/O interface techniques, so there are majorly two techniques are there. So I/O devices can be interfaced to a computer system I/O in two ways. The first one is the memory mapped I/O, and the second one is the IO mapped IO. So memory mapped IO in the sense in simple. So memory mapped IO in the sense here everything is going to be in combinedly for memory and for input and output. It is going to make use combinedly. But when it comes to the IO mapped IO, so the memory is going to be separate and the input output is going to be separate. So that is the quick difference between the memory mapped IO and the IO mapped IO. So we'll be going to see clearly what is a memory mapped IO and what is an IO mapped IO. So this is the memory mapped IO. So second one, this B indicates the memory mapped IO. So here if you have seen this here, only one address space is there. That means for this address space is going to be used for memory as well as for IO devices. Fine. So this is the main point you have to remember when you people are going to talk regarding this memory mapped IO. Fine. So memory mapped IO in the sense there is no special IO instructions. Why? Because only that the space which we have provided, that space is going to be used by the memory as well as the IO devices. Fine. And IO mapped IO in the sense, as I have said you before, there will be a separate space for memory address and there will be a separate space for IO address. So this separate space we have divided whatever the total amount of space is there. From the total amount of space only we have divided memory mapped IO and the I mean IO mapped IO memory address space and the IO address space. But when it comes to the memory mapped IO, there is a single address space which is commonly used by the memory as well as the IO devices. So that is the major drawback. So if you want to reduce the memory address space, we allot a different IO address space apart from the total memory space. So that is the advantage of this IO mapped IO. So memory related instructions will not work when it comes to the IO mapped IO. Why? Because we are talking regarding only the input and output devices. So that's the reason memory related instructions won't work in this IO mapped IO. Processor use these modes only for input read and input output write. For not they are not they'll be not going to use for any other purposes. Only IO read and IO write. So let me have a at a glance what is the difference between the memory mapped IO and the IO mapped IO. So the first point as we have discussed, so memory and IO shares the entire address range of the processor. Fine. So whatever the space is there, both memory and address is going to be shared by this address space. But when it comes to this IO mapped IO, we have to provide a separate address range for the memory and separate address range for the processor. So that is the difference. So here combinedly we are doing. So processor provides more address lines. Why? Because combinedly for the memory and for the IO, in the sense more address lines we are in need of. But when it comes to the IO mapped IO, we need less number of address lines. Why? Because for memory there will be a separate address lines and for IO there will be a separate address lines. But when it comes to the memory mapped IO, we have to combinedly take the address lines for the memory as well as the IO. So that is the second difference. So more decoding is required. Why? Because lines are going to be more. So ultimately decoding is going to be required. Here less decoding is required. Why? Because here the space is divided into two. So decoding 100 instructions is very hard when compared with decoding 10 instructions. So memory mapped IO in the sense decoding 100 instructions. IO mapped IO in the sense decoding only 10 instructions. Why? Because this 100 has been divided among the memory as well as the IO. So that is the difference. And the last difference is memory control signals are used to control read and write. Here IO in the sense IO control signals are used to control the read and write signals. So these are the two ways how we are going to use this IO devices, accessing this IO devices. So memory mapped IO and the IO mapped IO for 2 marks it is very important in your final exam. Right? So you have to write this what is a memory mapped IO and what is an IO mapped IO. That's it, right? So this is how we'll be going to have the memory mapped IO and the IO mapped IO. So when we are going to have this one, we'll be going to have a very good interaction between this memory mapped IO and the IO mapped IO. And that's all for today's class, students. So in this today's class, we have discussed regarding this, like what is a memory mapped IO and how we are going to access those IO devices by making use of an interface. We are going to access the IO devices. Fine. That's all for today's class, students. Thank you. Have a great day.